Ladies and gentlemen, it is a great honour to be given this 2013 Computer Pioneer Award by the IEEE Computer Society for my contributions to the design of the early ARM microprocessors. Thank you for this award, and I am very sorry that I am unable to be present to accept it in person. I'll begin with a few words about my background and career. I was brought up in Manchester in the industrial north of England. I went to Cambridge University to study mathematics and stayed on to take a PhD in aerodynamics, applying ideas from the observations of the wing motions of very small insects to improve the efficiency of jet engine compressors. During my PhD, I used computers a lot and developed an interest in them, and I joined the Cambridge University Processor Group, a society for students who liked building computers for fun. I built my first computer using a Signetics 2650 8-bit microprocessor. When Herman Hauser and Chris Curry decided to start a new company to work with microprocessors, they came to the University Processor Group looking for potential recruits, and I got involved part-time. Then the company, which later became Acorn Computers, got the contract for the BBC microcomputer, and I joined full-time in 1981. The BBC Micro was a huge success, introducing computing to most UK schools and exposing a generation to the creative world of programming. I don't know how things are in the USA today, but in the UK we have become increasingly concerned that the use of computers in schools has been drifting away from creating technology towards simply using it. And many folk have been harking back to the era of the BBC Micro and trying to work out how we can recreate the excitement about technology that we saw in the 1980s. The ARM microprocessor emerged from the success of the BBC Micro. We were planning to build on its success, and in 1983 we looked at all the 16-bit microprocessors then coming onto the market. We didn't like what we saw because these processors were all very complex, which compromised their real-time capabilities, and they did not make optimal use of what we considered to be the key resource in a small computer, the main memory bandwidth. Then we heard about the RISC concept, so powerfully advocated by David Patterson and his team at UC Berkeley. It all gelled into this crazy idea to design our own microprocessor, the Acorn RISC machine. That's what ARM originally stood for. My close colleague, Sophie Wilson, sketched an instruction set architecture based on RISC ideas and her extensive experience of the requirements of high-level languages. I turned this into a microarchitecture, and a team of 3 experienced VLSI chip designers turned it into working silicon, all within about 18 months. In 1990, the same year that I moved back to academia in Manchester, ARM Limited was formed as a joint venture between Acorn, Apple and VLSI Technology. ARM's progress thereafter has been the stuff of legends, with a great many people contributing to make it a success. Today my work is focused on the Spinnaker project, where we are building 1 million ARM processor cores into a machine optimized for running real-time brain models, contributing to the quest to understand the inner workings of the ultimate computer, the one inside each of our heads. As with my PhD, biological inspiration is playing a key role, and we have had to innovate in order to model the very high connectivity found in brains. 30 years after the original ARM work, I still find the demands of innovating on silicon very rewarding, and working with bright students and postdocs keeps me on my mental toes. Thank you again for this honour.